very honored to be here presenting some mistakes, common mistakes, PV systems, CNI, and residential. And I'm thankful for the Tecloman event organizers for having me here today. Okay. So we are going to talk about common mistakes in planning and installation of photovoltaic systems, lesson learned from real-world examples. And first, quick background of me. I got my bachelor of electrical engineering degree in 2005 and MBA 2012 in China. 12 years of experience back in China, 8 years in Germany, and over a decade in PV industry. My expertise in identifying, correcting plannings and installation of the PV systems, either residential CNI, and also I'm the certified consultant and expert in photovoltaic systems. And in German actually, Gutachter. So first of all, we're going to talk about three different parts. First is the importance of proper planning and installation and maintenance of the system. So as you see here, the yellow color here presenting the sun shining from the early morning to the evening, and the green is presenting the amount of the electricity that we can generate from the sun if you have a good system according to the planning and also the installation. And the second one is showing an example that the sunshine is still there, but we are just generating small amounts of electricity out of it, either the installation and mistakes or the maintenance. So I'm going to show you some examples of poor planning, some examples of poor installation, and also some points about maintenance of the system. So as you see here, this is one way of having the panels vertical, horizontal, and you see here you have these shadings of 4 panels, but the other side you have. So sometimes when you change the directions on the planning, you will get even more out of the systems. And also, as you can see here, at least in Germany, we don't have any requirements to have to leave space between the edges of the roof. That's on the top left and right, so it will be higher, so you could have definitely no shadows on the panels. So you could use the top row as well. And here is the real world example. So the planner didn't think about this chimney pipe, and this is what happens. And this is in real world, this is what happens. So you go to this place, you find out this is a mistake, and also it's going to affect on the PPT, the MPP. I'm sorry, the maximum the MPP, and it's going to track and make at least 20 or 30 panels, like all of these panels on that string, really problematic. So the next slide is about the shadow. So in planning, sometimes we don't think about it. So we think, okay, we just put the panels on the right side, so we don't think about it. The shadow is going to be moving all the time. And also in summer and winter, we have different shadows. So this is affected a lot. And as you know, as long as you have 10% shadow on one panel, it's going to be affected in all of it, all of it. So the next one is a slide about the 3D generation of the shadow, like how it's going to move. So just leave away these 2 panels, you're going to have like 19% more generated from the panels, because with having based on the systems, you're going to lose 19.3, and your system is going to generate only 80%. And the next one is a common mistake number 1 that goes to courts in Germany. So you promise to the guy, okay, I'm going to build you 10 kilowatts or 20 kilowatts system, but at the end of the day, you will go and see, can't fit all the panels in. So the customer comes and asks you discounts because you couldn't put in like one less panel, which is like out of 10 kilowatts, it's like 4%, and he is going to ask you 4% discount. to provide because it's not logical. But this is what happens. So definitely no panels out of the edge of the roof. So the next one is a big, huge design plan. So definitely you can go over the edge of the building, and this is forbidden. And this is was designed like 12 years ago. So the time that everybody thinking like the best design, the best direction is going to be on the south, which is not correct actually. And you see here the shadows. You see here, like when you go on the left side, more and more shadows. You have here completely the panels are in the shadow, and this is definitely the way we don't have to do. Okay. And this is also same system, but picture from other angle. Here, so we have this plan. The planner planned it 60 kilowatts for one system, but the best idea would be two systems of 30 kilowatt peak. That if one of them is going to be like under maintenance, or let's say a problem with the inverter, so it's not going to affect the other system. And it's very good when you can split your systems and have them like under 30 kilowatts. The next one is the installation of the heaters. So here, as you see, they are on the corner, and they haven't think about the heat generating by the battery and the inverter. And usually it depends to the inverter producer, like sometimes 20 centimeters, sometimes 35, 40. You have to have a space between the inverter and the wall. And sometimes when you have two inverters, exactly what you see, if you take this 20 centimeters, for example, then you go here, so it has to be actually 40 centimeters because you have two, and you need to have between each at least double space. So definitely this is an overheating problem that happens. And also, as you see on the top, there are also four inverters, which is installed there, and especially like you have a lot of space, but it's wrongly just installed next to each other. And also here, so not only it's installed next to each other, the second problem is installed on the wood part, and it's fire hazard. And the same here, and because it was generating too much heat, so it connected these two inverters in between, and also this one, this one and those two. So three of them was shut off. Okay. So now I just want to talk about shortly about the wind and the snow pressure panels. This is just a typical picture. It shows the pressure of the wind on the roofs, and why we need this pressure test the panels, and why we need to install them correctly. So IEC 61215 is one of the international electrotechnical commission that is approving the panels, and it has to be like all of the panels. So like in all around the world, they have to have at least basically this certificate, and also for the light build panels like 61646, and it's going to show the pressure, like test the pressure on the front of the panels because of the load of the. So it's like at least they have to be for they have to stand like 550 kilos per square meter. So it's like a 2 square meters panel has to have a stand for 1,100 kilos of pressure on the front side and back side because of the wind, 245 kilograms. So here is some examples of installation errors. So first of all, you see here a big system, which was a commercial system, and it was blown away with wind because it wasn't, first of all, correctly connected to the roof, and just happened. And this one as well, so it's correctly connected actually to the under construction of the panels, but because of lack of the weight on the foot of the under construction, it just turned over. And this one the same. You see this type in the market at this time as well. But what they forgot to do is that to putting in the basket. So they didn't do that, and it happens by blowing the wind. And on the right, you see the hooks that's coming out of the tile, and they just measure this part. They can cut it out, but they measure it wrong. They didn't bother to come back and correct it. So the tile wasn't fitting on the roof, and the rainproofness of the building was gone. And also here you see the screw was not correctly connected to the rafter. And this is also one big common mistake that happens in the systems. So here you see on the construction problem, so under construction, they didn't have this horizontal under construction, and they make it vertical. And this is what happens. Some of the panel fell down, and the other was just like a hazard day or two that happens. The next one, you see this connection, auto window, you have to have it free, and it can in summer and winter a little bit, but they fix this to the and it moves just cheating the this is what happens. So when you have these connections, you just have to make them just to make them to loose and move those. Like for 6 meters long bar, you get like 2.9 centimeters. You need to leave space for it to move freely. And this one is also after the installation, they find out when the automatic doors they get open, they just hit the panels. So this is also something that's on the installation part of the system could be figured out, but not by the planning, because at the planning it wasn't it wasn't possible to open the doors. You see, this door is okay, but this and the other one is not, is hitting the systems. And also, of course, if they're not going to hit the system, is also they're going to generate big shadows and affecting the systems. The next one is about shadows. So moving shadows on the right and also on the left, you see there is a shadow, and here you don't have any sunshine, so it's going to affect the whole string, which it was all one string on this side. And this is also importance of the shadows, checking the shadows and the place. Sometimes it's better to have this with tools of 3D generation shadows, like you can check out, like 𝑷𝒉𝒐𝒕𝒐𝒗𝒐𝒍𝒕𝒂𝒊𝒄 softwares like that, to find out where the shadows goes, and that's going to affect a lot. The next one is also about shadows. So on this side, see the shadow of this building exactly on the roof, and as I said, we don't have to keep any distance legally from left, right, and open. Just on the bottom side, you need to leave 50 centimeters. So they just use the maximum of the space. But these 4 panels are going to make them almost generate only 10%, because the 4 of them are almost 90% shadow on the whole string. And also here, so you see the street lights having a shadow on the system. You can see it here more close. On this side is the air ventil that is covered by the panels, but actually you're going to see, okay, you don't have, it's not touching it, so it's going to be okay. But the point is, it needs space, it needs to the airflow. It's like to it needs to have the airflow and the space. So it's like what happened is going to be really affected. And also on the right side, you see some shadows. That's going to, so this part could be easily removed by the installation time, but they didn't bother to do that. And also here, you see that under construction, the cabling of under construction, it just fell down, and it's going to be, it's also a fire hazard, a matter of time. It's going to be maybe 10 years, 5 years. So by wind, it's going to be moved a little bit by time by time, and then the cover of the wire is going to be away in a couple of years, and then it's going to be a fire hazard when you have at least 1,000 volts in the
Is everything all good?
Yeah, but this one, I think,
Oh,
just a minute. It's good to take a break. Wash all the day. It's like an extra 2 hours in the traffic.
try it again.
Now?
Yeah, very good. All good.
Okay, good. So it's going to make a good difference.
No.
So okay.
Okay.
I hear it again. Yeah. So maybe you can speak louder.
Yeah, I think it's.
It's okay. All right.
So you have this is to the
But I have to work with this one or without this?
yeah. I have to work
But this is what
for
happens. See?
recording. Yeah.
So okay. As you see here, this is the PV part, the solar part. That's the high you can see. The panel was not tilting the array, and also the net mirror connection extended to the by the side of the inverter, which is bigger than we can do that. Because of some different reasons. And the next one is control group. It's like it has the minimum hyper. This is like because it's there's one like on the group for a long time, or like some these parts. So feel that the story is not stable, so they could record it. It's like an acid, so they do it afterwards. And also this is some example waterproofing. It didn't work actually. This happened, and also these options. So just a matter of like maybe 2 years, but after qualifying and the roof also. And here you have this decoration. They didn't treat the washer, the plastic washer, and the so water is really fine. And the second one, they bring the extra holes and they find out what the top right, so they do another one where they didn't cover it. So I'm here, but they try to teach them and go. And also here, you see it came out of the edge of the root. So too much just can be through the borders of the root. Also, we see the screws here, and also this screw here is done correctly to the rafter. Here you have a better picture of it. So the screw is short actually. Here, and also the screws they use here, this has to be advanced 13 to 15 centimeters, but those where they have like 4.5. And here, definitely this is not the correct way to fix the system to the road. That's you. This part, that is three, you have this Bluetooth. And the open with the binder, they put on this side. It's not okay because it doesn't have, as you can see here, better it bends when they have this. So all of these bend. So on the last from the last to the right or to the left, they're not binders, and they're like nobody. Sometimes the people put them on and make mistakes. And also here, so the installer decided not to connect these aluminum bars because final phase, so it's going to use 6 binders. It's going to be expensive. and we didn't use this. And here the file has already been cable. So you see this is the mess, so if you want to change it, you don't want it to take always to reach the part, and also like the cables are falling down. On this side as well, the cables in water. This one, the mess. After 12 years, so the system that under construction, the under of the panels just look like that. And also this wiring cable, like they use this too, but this is longer because when the rain comes, it just helps the water to get in, and the whole cabling stays in water. Okay. And also here, so you have the pressure cable in the AC4 connectors. Here they decide to use some glue to fix the cables to make sure that the cables are coming down the hill. And here you have pressure on the cable, and not considering that winter and summer is going to be more or less, and also those that cables are low and the might be. And also here you see that there is a big inverter under a panel. You see, it's on a solar park. They put it, it's in a roof, big commercial roof. They put it just and also this is the other one residential installation that they feeding the cables to the building on the roof, under the pipe. So these are the rafters. The pipe and the just whole and pass through the cables, which is not okay. And also here, so we see this connector. It's not correctly connected, and they haven't used some proper installation. And this is what happened. So the system was not working right. And then we called and also here, so you see this is also installation method. So they made it so on the top, and then they feeding the cables on the top, and then the water comes and just gathered inside. So what you have to do is that you have to bring always on button when you are using the stationary things outside. Is like installer and a proper person must know this. And also here, so you have at the end of the aluminum bar, you have this clamp that's not actually correctly used. So that would be at least 15 or 10 to 15 centimeters longer than the aluminum bar. And here you see is instead of a T-clamp, they use the bolt with the washer, which is not right. You have to use T-clamps or both clamps like this. So also here another one that you have this aluminum thing under, so they extend this aluminum, and so they just put it like this. So what they have to change the aluminum bar has to be on this side for the aluminum bar.
USB na natin.
First here you see this 𝐴𝒐4, which is melted. And also here you see the bar, you see the L clamp, but it's not touching the bar. So this thing happens. So people go and install and then nobody checks. No. Also here it's grounding. Not correctly grounded. Here you see typing too much, which go the part underneath. And this is the example of the cabling. So under construction, they use zip tie and exactly 2 zip ties at each one, which is correct. So they try to make everything in order, just to make it clean installation. Aside from the cable and the cable. This is one of the good examples. Here also the same. So it's a solar park in 2 inverters. So the layout is very good to take the cabling routes, and also the inverters protected under the panels, but not too much in the panels, like leave it out so it's protected from the rain. but it's also can have really good ventilation. So the next one, the next part, which is the last part, is about the maintenance. So ensuring like the maintenance of the system is correct. So measurement. First of all, the most important thing is cleaning the panels. Most of the panels have the performance of the panels, as you see here, and also disconnecting the insecure in the daylight. So this is again, this is what happens like 1,000 volts of voltage you have inside. And also here, you see, for some hotspots, we have to find out, we have to change the panels, but we have to do maintenance. And also here, under the panels, some dirt and debris that's gathered. So this is also very important with this quantity of maintenance. So you can keep most of the time, like twice a year or so. And here you see the ties and cabling, which you actually very comfortable. Lost it has to be like the plastic institute. And also here, so if you go through the maintenance and you don't do the checkups, you don't know like why the monkeys are there or not. But you have a system, you have a big system where solar parks supply the solar parks are there like every once a month. And also here, so some pressure and the installation after some here make this happen. And here you have some problems from the panel. Inside the panel of the there now. So visual expression, like a lot of times with a lot of information and find out like mistakes that come. Here you have another example of the battery cabling, which is supposed to connect to the construction, but it's not. So when it's rain, before stays in the water, and goes into. So the next one here, you have this inverter. And down the inverter, it has to be clean to make sure if there is any like anything happens to the inverter, to the cables, you can find out when it is dirty. So we have to look about it's going to look like clean the system, like once or twice a year to make sure that everything is in order. So when you just go and check the cables, you can find out sometimes mouse like biting and the cable, so you haven't find out like the C box also means something. So also here, so you see with that affecting shadows on the panels. So it's very, very important to have maintenance, regular maintenance, and closing the glass, and you'll have a solar. And also here, the internet will change. Find out that we have to change that connection. And also, the next one is about with several higher camera, I would think that you cannot easily see your eyes. So, firstly, this is the space mix that will have like go to the panels a bit bigger, so you have to have the quickest same distance between all the panels. And everybody can see without you don't see much. See just a little bit from right now. What we see here with the camera, you can find out these there and some way how because thanks for the first thing. Louder? Okay. All right. Okay, so here you see some hotspots. So this is only with either camera you can find out if there are like problems in the cells or like which cell is like the temperature in which cell is higher. And as you see here, it might be maybe these three are like ultra further, like the others are going to join them in the future. But see exactly there, three hot spots. So these either cameras and checking with them. Checking is going to be really important. And also on this side, you can easily find out that this bypass field of these two rows are already out. So the whole two rows is not because it cannot pass electricity. The bypass field of the second row is also too hot. So it might be also in the future going wrong. It's already like one third of the panel is out. And here you have a hot spot. The front there. Here you have exactly to bypass your so you cannot generate electricity in these parts.
So the whole string can fall down. The whole string.
Not the whole, yeah, the whole string, but let's say the whole string is one third of the whole string. And also here you see the panel shattered from inside. So it's too hot and from inside. So we've got the hottest spot, but for two actors like that, so it's shattered. The glass is broken. So this you can find out easily with a visual inspection. And also here, you see that it was too hot, and this is also on the back of the panel, and it was too hot that it made it just burn from inside. And as you see here, you have two streets, and this string is okay, but the second street, which is from here, it's not working. So the whole string is not working. You find that like when you find such kind of hot spots on most of the panels which are on one string, so it would bring you in mind that it's going to be the string somewhere the connection is not connected, so it's for the cables and other fusion to the support. And here, some more examples with the rear camera, what you can find out is the bypass field is totally out. This one is too hot. I think it's also the same. So as you know, like each panel, they have three bypass fields, and for each bypass fields are connected to two rows. So we see there and there. Here we have three rows out of two rows out of three panels. And then we see here. So these panels will look okay, and those two falling down. So that was also one of the good things that we have to do with maintenance that they are falling down. And also here, so sometimes it's totally out, but sometimes it's like with question mark. It's like is it working? Like one string, one bypass fuse is out, or two of them is out. So we just have to go and find out. But we don't, when the IR camera, we didn't have this picture at all at the beginning, so it's going to help a lot.